Alright, so let's check out your exam 2 prep. Alright, so this is version B here. Okay, so first question, true or false? It says the y-intercepts of the graph of a function y equals f of x are the real solutions of the equation f of x equals 0. So if we recall, to find the y-intercepts, we must set something equal to 0. What is that something? It should be x equals 0, not y equals 0. So this would be completely false. Alright, so if you want to find the y-intercepts, you set x equals 0, not f of x. Number 2, every polynomial function of degree 4 with real coefficients has at least one real 0. Alright, so that is false because we could end up with a graph, as some of you saw, that might do something like this. So this function here, this polynomial, does this polynomial ever cross my x-intercept? Well, the answer is no in this particular case. So for that reason, this would be false because every polynomial function of degree 4 with real coefficients does not have at least one real 0. So all these zeros would be imaginary because none of them actually crossed here. Alright, number 3. A polynomial function with x plus 2i as a factor will have 2i as a 0. This one's tricky, right? Because we know if x plus 2i is a factor, that means that your 0 is going to be automatically negative 2i, right? Because it's always the opposite of this. So it's negative 2i. But we have our conjugate zeros theorem that says if one of your zeros is minus 2i, then that makes your other 0 what? Good, I heard the person in the back say positive 2i. So this one is true. So if they give you one of your imaginary zeros, they actually give you your other one as well, the conjugate. Okay, question 4 here. If a polynomial function p of x is divided by, it should say, divided by 2x minus 3, and 5 is the remainder, alright, so with the remainder factor theorem, the remainder theorem, if we want to simplify that, alright, so what that remainder theorem says that if I go ahead and plug in my value of c here, my value of c, I should get 5. But here, they don't, this 3 is not this 3, because that only works when they give you x minus 3. But what do they give us here? They give us 2x minus 3. So this does not imply this. If they gave us x minus 3, then we absolutely can conclude this. But here they give us 2x minus 3. So this is absolutely false. Okay. Number 5. A polynomial with degree 4 and leading coefficient of 5. Alright, so our degree is even and our coefficient is positive. The following end behavior. So we know if our degree is even and our leading coefficient is positive, what we're going to have to the left, it's going to be increasing. To the right, it's going to be increasing. So it should say as x goes to negative infinity, f of x goes to positive infinity, so that's good. And as x goes to positive infinity, as we go to the right, f of x goes to negative infinity. Well, it should be going up to positive infinity. So this should be positive infinity. So this is false. Alright, so there's a look at our true-false questions, 1 through 5. Alright, so again, I think the most confusing part is number 4. So again, if they would have said, if you have a polynomial function p of x is divided by x minus 3 and 5 is the remainder, that would imply this right here. But this is only true when there's a 1 right here. We can't have any other number. Alright, so that 2 messed everything all up. Alright, so we'll catch you in the next video. Thanks for listening to Math with Dr. Math. Catch you later. Oh, you guys saw that. Let me pull that out real fast.